In this video, I'm going to do 3 questions from the chapter Relation as for class 11. So let's begin with the first question over here. What you can see in the first question, it says, if the ordered pair a minus 2 and 4b square belongs to the relation xy such that xy belong to z, that means integer, and the definition here is y is equal to 2x minus 4. So first I'm writing y is equal to 2x minus 4. As you can see, first is a comma minus 2. That belongs to this relation. Therefore, a will satisfy x, a and minus 2 will satisfy, that this ordered pair will satisfy this equation. Now what I'm going to do is to replace y with minus 2, and x with a. So replacing x with a, what do we get here? That is minus 2 plus 4 is equal to 2a. That implies this is 2 is equal to 2a, or I can say a is equal to 1. Now, the second part over here, as you can see, there is another value, that is 4, or another ordered pair, 4b square, right? This satisfies this relation again. So we can plug in x as 4 and y as b square. So it's going to be b square is equal to 2 times x, and x is what? X will be replacing with 4 minus 4. So this gives you what? B square is equal to 4 into 2 is 8. 8 minus 4. So b square comes out to be what? 4, and b, as you can see that a and b belongs to integer. So it will satisfy both the values, that is plus 4 and plus 2 and minus 2. So b can be 2 or minus 2. So we have these as the values of a and b. Now see the next one. The second question is, it says let a be a set, as you can see it's minus 2, minus 1, 0, 1, 2. Then what we have to do is to write the ordered pair of each of the following relation a, and the condition here is that a, the first part is a greater, is greater than. So is greater than, what does it mean? It means to say we have to form some ordered pair here such that we have to form such some ordered pair, right? As you can see, it's an ordered pair. So is greater than means what? The first has to be greater. Like if I begin with 2, for example, then 2 is not greater to than any number. So let's discard 2. Then I'll write, 2 I should write. 2 is greater than 1. So 2, 1. 2 is greater than 0. 2 is greater than minus 1. And 2 is greater than minus 2, right? So 2 got exhausted. Now I'll start with 1. 1 is greater than 0, right? 1 is greater than minus 1, and 1 is greater than minus 2. So this also got exhausted. Now check for 0. 0 is greater than what? Minus 1, and 0 is greater than minus 2. Now next is minus 1. We can see minus 1 is greater than minus 2. Right, so minus 2 is not greater than any one of them. This is how we will do the first part over here. Check for the second part, is square of. So if I begin writing from right hand side, 2 is not a square of any number as for this, right? But then we can see 1 is square of 1, and 1 is also square of minus 1. 1 is square of minus 1. Further, you know that 0 is square of 0. That will also go. And minus 1 cannot be. And negative numbers are not squares of any number. Now next is negative of. Is negative of. So this was our second part. This I did. The second part over here. Now if I see the third part, check for the third part. In the third part, it says is negative of. So we know that I can write 2 is what? Negative of minus 2. Right? Or you may write other way also. I can say that minus 2 is negative of 2. Minus 1 is negative of 1. And negative of 0 is 0. Right? I can say 1 being negative of minus 1. Right? Negative of negative is positive. And similarly, 2 is negative of minus 2. So that will be the way in which we'll do the third part over here, right? This one is the answer for the third part. Now we have one more question over here. Let's go. In the third part, it says let R be a relation over here. XY is an ordered pair such that x square plus y square is equal to 25 be a relation defined from the set Z as an integer. And in the first part, what we have to do is to write this in the roster form. Write R in the roster form. All right, what we are going to do, first of all, I will write this, say x square plus y square is equal to 25. Now we have to take integers, right? So taking two integers which will satisfy this. So I can see if I take x as 0 and y as 5, so which is equal to 25. So I'll say that 0 comma 5 is one such ordered pair. Conversely, let's say this being 0 only, but if I take this as minus 5, still it is true. So I'll say 0 minus 5 is also true. And in fact, we can shuffle the order, right? And we can shuffle the order and still it remains the same, but the ordered pair is different. So 5, 0 and minus 5, 0. Now we'll check for other such number. If you remember the Pythagorean triplet, that is 3 square plus 4 square is what? 5 square, that is 25. So I'll say that 3, 4 and 4, 3 are such ordered pair. Now check here, we know that this is squared. So if I take minus 3 square, keeping this as positive, we still have 25. So that is minus 3, 4 could be minus 4, 3 could be minus 3, minus 4, right? These are the possible combinations that can be made from the integers. So now if I talk about the domain, let's check for the domain. Domain is what? Domain is the set of all first values, right? First number in the ordered pair. So domain, which is actually a set, you know that. So I can see from here, if I keep writing, this is 0, then we have 5, minus 5, we have 3, 4, minus 3, minus 4. And same way, we can get the range here. The range is what? The set of second element. So 5, it's minus 5 if I am looking like this. And then we have 0 as 4, 3, and it's minus 3. Yeah, minus 3 also has to be there, right? 1 minus 3, that is minus 4. Minus 3 is also true as, so it's minus 3 and minus 4. These are its range. So that's how we'll do this question.